So my name's Jason. I'm the CTO and co-founder at Puffer Labs, and we're building the Puffer protocol, and now that is extended to Unifi. So I'm super excited to talk about that, and really the whole point of this talk is really we have this strong belief that the future is based. And by based, I mean based rollups. So before we really get into that, I want to give a background about what Puffer is and what really allows us to build something like this. So today, Puffer is a LRT, so liquid restaking project, and we have a couple players here. So stakers, they are our capital providers. They bring ETH, and that is used to fund validators. Puffer validators, importantly, are permissionless. So to run one, you need 2 ETH. And you pay these things called validator tickets. And this was a mechanism that we introduced that allows us to have low bonded validators in this permissionless setting. So the validator ETH is used to fund the stakers. In exchange, validators actually get to keep all of the proof of stake rewards that they generate. And this is more incentive aligned and allows us to get around things like MEV theft that happens in other protocols. So on the right-hand side here, we have restaking operators. So Puffer is an LRT, so we're operating different AVSs. So together, this is the Puffer protocol. And importantly, our mission here was to find ways to really help make these validators more viable. That meant bringing down the requirement from 32 ETH down to 2 ETH, and in the future, even lower than that. And also to find additional ways for revenue. So this is why we started working as a native restaking protocol where our validators' ETH is restaked and they're able to earn additional revenue through these AVSs. So now on to Unifi, and you might be thinking, oh no, not another L2. We have enough of those. But really, what we're trying to do is introduce this new paradigm called based rollups that have a lot of great advantages over the systems today. But before we get there, it helps to really talk about like, what is the status quo? So today, this is like the kind of traditional setup for a rollup. You have users can send cheap transactions. They go to a centralized sequencer. And their job, just like the name implies, is to sequence transactions into this canonical order. And then they post those to a data availability layer. Typically, this is Ethereum, but it could also be an alt-DA like EigenDA or others. So the idea is that embedded within these transactions are these layer 2 blocks. Usually, like since the last update, these are in the form of blobs. And really, the nice part about this setup is when a user sends a transaction, they're able to get a really fast confirmation. Like, as soon as the centralized sequencer receives the transaction, they get this handshake that says, your block will be included in the future. So there's some issues with this, though. And I really want to go through each one here. So the first one is around centralized sequencer risk. In crypto, we're always striving for decentralization and trying to minimize these points of failures. And centralized sequencers are one of those. Another one is this liquidity fragmentation problem that we're having, where there's hundreds and soon to be thousands of rollups, but none of them are able to talk to each other. And this really has this negative sum game that really hurts the liquidity for users and like the sort of potential for Ethereum. And the last one is about economic misalignment, where value is sort of leaving the L1, and that could be detrimental in the long term when the L1 is meant to be this really secure settlement layer. So now to kind of analyze some of these things, when a user sends their transaction to the centralized sequencer, there is risk involved here. One of them is a liveness issue, and this can be in the form of censorship. It could be in the form of just a faulty sequencer. If they're offline, it's possible that your transaction doesn't actually make it on-chain, or if they censor you, you have to go around this really slow path usually called the escape hatch, where you can submit your transaction directly to the L1, but you're losing these benefits of fast and cheapness. So another possibility, luckily we're not seeing it too much today, but there's this possibility of rent extraction through toxic MEV. And the idea is if a sequencer gets sort of big enough, like the rollup is big enough where a user kind of has this, this desire to stay. This can be a vendor lock-in issue where sequencers can start to extract toxic MEV and a user doesn't really have an option to go bring their assets to the next rollup. And finally, down here, one of the issues around soft confirmations is that they're soft. There's nothing really economically binding a sequencer to uphold this confirmation, so they can sort of give you this handshake and then just censor you again and fail to put it on. So another risk or like issue that we have with the rollups today is around liquidity fragmentation. So right now we see, like, in this example, let's say Uniswap exists on this rollup. We got Aave here and Curve here. They all have different amounts of liquidity, different user bases. But at the end of the day, if I'm a user and I want to send a transaction, maybe I do a swap on Curve, and then I want to do a swap on Aave, there's really no good way to do that today. Like, there's different paths. Like, one could be I do a swap on Curve, and I'm on an optimistic rollup, and I wait 7 days, exit, bridge it over here, then do my Aave deposit. Not a great UX. We can deal with bridges where we have like liquidity pools on either side, but now we're introducing these third-party risks, and bridges have famously been hacked again and again. So it's not really something that we want to bet on in the long term. And another one of these issues is around value capture. And this was what I was talking about with economic misalignment. The idea today is that sequencers capture all of the MEV from the transactions that they post for their rollup. And this is taking a lot of value sort of out from the layer one and sort of into the pockets of these sequencers. And over the long term, this is less value flowing to the L1, which means less ETH is burned, and maybe we're going to keep seeing issuance and the value of ETH going down. And this is terrible when the whole premise of this rollup roadmap is to build on top of this strongly secured settlement layer. Right, so to recap, these were the three risks. We have centralized sequencing risk, we have liquidity fragmentation being this negative sum game, and this MEV extraction forms this economic misalignment with the L1. So how about based rollups? Like, what do they do to solve this? So really, the key thing here is the idea of shared sequencing. Like, there's lots of protocols that are talking about this, like Espresso is one of the companies that might come to mind. And the idea with shared sequencing is we're taking this job from like one centralized sequencer, and we have some kind of leader election process where there's multiple different sequencers taking turns. And in that sense, it's a little bit more neutral. Like, if one person is extracting all this MEV, well, maybe the next person in the sequence or in the round robin won't do it. But what is like a better platform if we want to have like a very credibly neutral set of these decentralized sequencers? That would be the Ethereum validators. So what a based rollup fundamentally is a normal rollup, but instead of sequencing it with one person, you're sequencing it with the Ethereum validator set. And the election process for that next leader comes for free because it's just the next proposer of the L1 block. So maybe to walk us through this process here, if a user wants to send an L2 transaction on a based rollup, they're going to get the same cheap experience because all of the execution is happening off-chain. But now, the sequencing is done by the next elected Ethereum validator to propose the L1 block, and this allows us to get this strong robustness guarantee. So before we had this issue of liveness, where if the sequencer is offline or censoring you, you're kind of out of luck and have to go through this escape hatch. But now we're inheriting the same robustness as the normal L1, where if this person misses their block, well, you have the next validator in line to be able to include your transaction. And one of the main things here is speed. So based rollups as an idea have been around for about a year now, but the idea of how do we provide the same exact user experience has been missing until recently. There's been a breakthrough in preconfirmations. There's this idea where we're able to get all of the properties. So you get a confirmation that your transaction will be included, but you can get it within 100 milliseconds, similar to what you'd get from a centralized sequencer. But now the idea is that if the sequencer decides to try and break their promise, they would get slashed. And this would happen through some kind of protocol like EigenLayer. So what we're giving the users really at the end of the day here is the same exact user experience, but we're getting rid of like all of the bad things that can happen and giving stronger guarantees of inclusion. So how does this address the other problem? So now shared sequencing and by extension base sequencing is the first step that you need to actually achieve this interoperability between rollups that doesn't require you to use things like third-party bridges. So what a based rollup ecosystem would look like is an app chain, in this case Curve, could actually you can send a transaction to Curve, it can go to Aave, it could go like hop between all of these atomically. And that's one of the big words, atomic execution here, is that like if I fail in step 3 over here, then all of my transactions are going to revert along the way, which is not something that any of these bridges are really able to guarantee. So finally, the last point here is that we talked about value capture. And in this case, the sequencing is done by the Ethereum validators. And so the actual MEV revenue is flowing back into the layer 1, which can then be burned once we have these things like MEV burn added, enshrined into the protocol. And this really helps with the long-term sustainability for Ethereum. So with that note, like, what is Puffer Unifi? So what we really are hoping for is to kickstart this ecosystem. Like, I think hopefully I've convinced you that based rollups are something to consider here. But for this vision to really take off, there needs to be lots of based rollups that are able to interoperate with each other. And so Unifi is the first step in that direction, where we're trying to create a based rollup and make it easy for other people to do so as well. So just at a high level here, there's a couple components. And because this is restaking day, I'll focus a little bit here on the pre-confirmation side. So we need to be able to add additional slashing conditions onto Puffer validators. So the idea is a user can send their rollup transaction to Puffer validators who are under these additional constraints. And they're going to propose, like, sequence the rollup transactions and publish them to the L1. And this is going to allow additional yield to flow back into the Puffer LRT and allow sort of Puff ETH holders to capture some of this congestion and contention fees. And what this comes into is we're trying to build out an app chain ecosystem where people can start to run their own app chains. Like, if you start to fast forward into the future here, when we have this idea of like synchronous composability where different rollups can interoperate with other rollups, then like sort of the idea of a general purpose rollup starts to break down. Like, if I can capture my own revenue, let's say I'm Uniswap and I want my own app chain, like now I'm able to capture all of the sequencing fees for my own product. And sort of the bet that we're making here is that in the future, a developer will write a smart contract, and just like deploying it to the L1, they would deploy an actual app chain. And this is better incentives. Like, for example, let's take an application like Farcaster, let's say, and maybe that's driving a lot of the sequencing fees for a rollup. Really, they should be capturing a lot of these fees themselves. So now they would be able to build their own, and they would be able to tap into the same shared liquidity and user base across the other rollups that are also based. So what does this look like from the point of view of a developer? So right now, there's a lot of friction. If you're like an aspiring developer, you have a new application you want to launch, you have to pick. Do I go to Arbitrum? Do I go to Base or Blast? Or which of these chains? Because a lot of the success of my application really depends on the success of that ecosystem. In this sort of based future, when everything's interoperable, it doesn't really matter. You get to launch your own chain, and there's no maintenance. Like, you're not running your own centralized sequencer. It's being done by the Ethereum validators. And this allows you to compose with other rollups and capture your own congestion fees. From the user's point of view, not much is changing in terms of the user experience. You still have the same rollup experience, fast and cheap transactions. But the best thing here is this unified liquidity layer. Like now, if I do a swap on Uniswap, I'm sort of getting the best price instead of having to do my swap at the Uniswap pool on the biggest chain. You're kind of pooling together all of the Uniswap liquidity there. And then some of these other things are sort of less known by the users, but you're going to have just a more robust experience, and you're going to have a more credibly neutral sequencing, less of this rent extraction that I talked about at the beginning. And so to really wrap this up, kind of what we're looking for here is we're trying to build out like just the first sort of piece here and make it easy for everyone to run their own based app chain and interoperate with other ones and sort of usher in this new based rollup paradigm where eventually like more and more validators are going to participate, and hopefully like that is the next step for Ethereum. And thank you so much. I'm happy to answer any questions. Cool, thank you.
Hey, when you talk about app chains, my mind automatically goes to the Cosmos ecosystem. Are we expecting a similar user experience in terms of needing to bridge from each app to the other one, and each app having its own token as a gas token, basically? Or is it, like, how is the user experience going to look from that perspective?
Right, so I think it is very similar in that sense, but what we're really tapping into is like the Ethereum L1 being that shared liquidity layer. So transactions kind of are routed in that direction. So we're seeing a lot of like innovations on the chain abstraction sort of landscape. And from the user's point of view, this will all just be one wallet click, hop around to different app chains.
Anybody else?
I didn't get how do you do the revert when you have multiple cross-chain, cross-rollup failure. How do you do the reversion?
How to do conversion?
How do you revert?
Oh, revert. Yeah. So this is the idea of atomic execution, and so really the first step there is you have to have the same sequencer operating multiple rollups at the same time, where they can guarantee one that your transactions will be included across multiple rollups. But the stronger guarantee is that they can guarantee that the transactions will also execute on all of them. And so there's designs where like you can, if the sequencer includes transactions that revert, so essentially you did half of the steps there, like transaction 2 succeeded, but transaction 3 failed, and then they still included transactions 1 and 2, then you can slash, essentially. You can do a fraud proof that punishes the sequencer.
Anybody else? Okay, then let's give a warm lot of applause for Jason once again. Thank you very much.
Thank you.
And we'll be continuing a couple more minutes.